Right? Now, first off, in terms of a log function and what the graph of that would look like. So, for example, let's get some values here. So on the toy, what is the log of 1?
0.
0. What is the log of 10? 1. What's the log of 100? 2. Okay. Okay. And then if we go to numbers, what is the log of 0.1? -1. What's the log of 0.01? -2. And then if we did 0.001, that would be -3. What is the log of -5? Error. What's the log of 0? It's also an error. Okay? So I can only do logarithms of numbers that are positive. Right? So if I graph my log function, it's going to look like this. So that'll be my graph of my basic log function. Right? It looks like that. Right? If I graph y equals 10 to the x, it looks like that. This was my exponential. This is my log function. My domain for this one, my domain is x can be all reals. So my domain is all reals. I can do any number. My range was greater than 0. When I come down here to my log function, my domain is greater than 0, and my range is all reals. They're inverses of each other. Right? And that's one thing true about inverses, is that the domain of the one becomes the range of the other. Right? Right? And so just like we did last week with the exponential, we can talk about moving this up, down, left, and right. And it works exactly the same way as it did with that stuff when we talked about exponentials. So if I had y equals the log of x plus 2 plus 3, now I want to know what happens to this graph. Again, I'm only worried about one point. This time, the point I'm worried about is the one right here. I'm going to figure out where that point is and then draw in my basic shape. So, what does the x plus 2 do to that point?
Moves it to the left.
It moves it to the left. So my point was here. It goes to the left 2. What does the plus 3 do to that point?
Down, up.
Moves it up. Okay? It also moves the s of the plus 2, moves that line over, and so my graph is going to look like that.
So the plus 3 moved it up.
Moves it up 3. And again, the left and right are opposite of what you think.
So the point is over 1.
No,
and up
and
3.
remember we started here.
Right.
So 1, 2,
Right.
and then up 3.
That's what I'm saying. It's over. It's to the left 1 and up 3.
Okay. 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 And again, so it works the same as what we did last week. As far as the up and down, left and right, same deal as that. Right? So my basic graph of a log function. Okay. And again, we can only take logs of numbers that are greater than 0. Now let's see, your toy can only do log base 10 or log base E. You got the LOG button and you got the LN button. Those are the two your toy can do. Well, what about if I wanted to know log base 3 of 75? And I want to know what that is. Well, I know that 3 to the third power is 27. I know that 3 to the fourth power is 81. And so 3 to some power, whatever it is going to be 75, right? After all, logarithms tell you exponents. That's what logs do. So I know my number is going to be somewhere in between 3 and 4. Okay. The way I get my answer is fairly simple. We use what is called the change of base formula. So for this, it ends up just being the log of 75 over the log of 3. You plug that into the toy, and you will get a number in between 3 and 4. And this number comes out to be 3.9299, so on and so on. Okay. Right. So if you do 3 raised to the 3.9299, you should basically be in the ballpark of 75. And that number comes out to be 74.996. So it is in the ballpark of 75. The more does, you know, if I would have gone out more places, I would be even closer. Okay. So we can do logarithms of any number by doing this. Now, for example, in terms of next week's quiz, if I want to know in terms of the log base 8 of 23780 is equal to x. Yes?
So would then, so for that last one we did log 3 to 75, would the answer be the number you got?
The 3.96 number, yes.
Yes, so
Yes.
that equals,
That would
is
be
the
the
answer.
Right. So in terms of this one, if I want to know if you want this in next week's test, how I know what that is. So again, you just do the log of 23,780, and then divide that by the log of 8. And so on the toy, if you do this, you should be coming out that x is going to be 4.8458 and change.
So that's all you need to do.
That's it. So you can do logarithms of any base, basically, by using this formula.
Wait, I have a question.
Yeah.
How come that didn't work for, I just did that for the first one that we just did? Like, because it was log of 3 to 75, and I just did log 3 divided by log of 75.
You divide it backwards. Yeah.
What?
It's the log of 75 divided by the log of 3. You get this answer. So here we did the log of 23780 divided by the log of 8.
Which is 3.73.
And up here, we did the log of 75 divided by the log of 3. Huh?
2.73, right?
For which one?
The last one is 4.
No, 4.84. You do log of 23780.
Just like that.
Log. Whatever to the 0.
Oh, there's a 0.
Yes, 23780. Okay. You're a little short. Okay. So try it again. But yes, it would be like that once you plug in all the number. Okay? All right? All right. So logarithms, logarithmic equation. So how about something like this?
Supposed to be
It's an I naught, yeah.
oh.
It's just that our board is likes to make gaps. There we go. That's a logarithmic equation. Right, Haley?
Mm-hmm.
So, if I naught, which is taken to be the threshold hearing, it is going to be 1 times 10 to the minus 12. Pressure, sorry. That's not right. That's pressure. Wrong unit. Let's see. Wait a second. Let's say I is 0.15 watts. I want to know what is my sound power level, and this number will be in dBs. So if I plug this in, we got LW is going to be 10 log 0.15 over 1 times 10 to the minus 12. So you plug that into the equation, you'll get how many decibels this will be. So to the nearest whole number, this will come out to be 112 EVs. That's a logarithmic equation. So decimal scale is logarithmic. Earthquakes, magnitudes are logarithmic. pH scale is logarithmic. So last week we had in terms of solving exponential equations for x, for t, for k, whatever it was. Today we have solving logarithms. So in terms of logarithms, there are some basic properties of logarithms. They come in handy for solving logs. They're not very handy anymore as far as getting the log of a number because everybody has the toy or the app, which will do the log of any number you want to plug in there. But not that long ago, you used to have in the back of the math book, you had trig tables and you had log tables. And obviously, you could not print out a log table that would give you the log of every number that there was. So you had to be able to figure it out. Okay? So in terms of basic properties, the first property is the product rule, which says that the log base p of m times n is equal to the log base p of m plus the log base p of n. That's the rule. Okay.
Is that B?
Base p, yes. Subscript b. Okay. Now, what does this mean in terms of how does this work? So, for example, on the toy, what is the log of 3 to 4 decimal places?
0.4771.
So 0.4771. What is the log of 5 to, again, 4 decimal places?
0.6989.
6989? All right.
I'm not rounding, I just cut it off.
Okay. And if I add these two decimal numbers together, what do I get? It's 4771 plus the 6989. Add those two together.
1.176.
1.176. All right. And now, on the toy, what is the log of 15? 1.176. That's the product rule. Again, like I said, at first, finding logarithms now, you don't do it that way, because again, the toy will do it for you, right? The toy doesn't care what the number is you plug in. It can do it. Right? So product rule. It merely says you add the two logarithms together and you get your value. Right? Next rule is the quotient rule. So product is multiplying, quotient rule is dividing, which means basically the steps are the opposite for my quotient rule. Okay? So if I do quotient rule, which says that the log base b of m over n is equal to the log base b of m minus the log base b of n. So if I think in terms of the numbers I just had up previously, if I had 15 over 5, so maybe I go backwards with what I had, and it would be this number minus this number will give me that number.
Could you also find the log, if you just did log 3 times 5, and log 15, log 15? I'm sorry.
Well, again, we'll see these. Again, these are going to come in handy in the next little bit. Again, we don't use these to get the log of a number anymore because the toy will do it. But we are going to use these when we want to solve for the variable. Okay? If I were doing it, right? And then the other rule is the power rule, which says the log base b of m raised to the p is going to be p times the log base b of n. So, for example, how does that one work? So, again, on the toy, what is the log of 2? 0.3010. What is the log of 8? 0.9030. What is 2 to the third power? Is 8. So 0.3010 multiplied by 3 gives you 0.9030. Okay. So we got product rule, quotient rule, and the power rule. And then in terms of the power rule, there is another variation of the power rule, which of course is very important in this class, and that is that I have the power, therefore I rule. Right, Haley? Think about it. All right, so we got those.
Wait, okay, so in that one, what number would be the p?
Well, really, we said that 2 to the third power is 8. So my p would be the 3.
And the b would be?
My base 2 in this case. All right? Or base 10 in this one, sorry. All right? So we got our 3 rules, and we'll see how they come to play in a moment when we solving. The other thing we're going to make use of, and we saw this earlier, was if I had y equals b to the x, we said that this became the log base b of y was equal to x. So being able to transfer back and forth, and you had that on today's quiz, between exponential form and log form, right? Right? So we'll make use of that. And we'll also make use of this, and that is if A is equal to B, then the log of A has to equal the log of B. And now whatever the base may be, it doesn't matter. But if 5 is equal to 5, the log of 5 has to equal the log of 5. And conversely, if the log of A is equal to the log of B, then A has to equal B. Right? So, properties of logarithms. Right? So, first off, being able to either expand or contract a logarithm. Okay. So making use of those three properties: product rule, quotient rule, and the power rule. So, for example, if I have something like this, and it says expand the logarithm. So let's do this. Log base 3 of x plus 2 cubed times x minus 4 over x minus 7 to the 5th times x plus 9 squared.
Seems a little extreme.
Oh, come on.
I feel like we've skipped a few steps.
Nah, we haven't seen steps.
I'm gonna write it down.
We just jumped to the next neighborhood. All right, we're going to write this down. After all, don't panic yet. Wait about 2 minutes.
This is hysterical laughter right now.
Wait about 2 minutes, then you can panic. No, it's not that
I
bad.
want to know it's
I'm going to expand this out. Okay, so we're going to write this all out.
Is that the dot? That's just part of the bracket. It's just
That is just the pen being the pen and the board being the board. Yeah, the dot is just a stray mark. All right, I'm going to expand this out. So maybe in terms of this one, I have product rule, I have power rule, and I have the quotient rule. I got all three at once. Right?
there's more rules than that, right?
No, that's it. So let's do it. Okay. So first off, let's start with the top. We got log base 3. Okay? And then we get the x plus 2. By the power rule, the 3 comes up front. Okay? That's what the power rule says. You bring the exponent to the front. Then we're multiplying, so that's going to be the plus. And then it'll be the log base 3 of x minus 4. And let's cordon off that first part in brackets. Okay? And then it's divided, the fraction bar, that corresponds to my subtraction from the quotient rule. Right? And now we do the same thing with the bottom terms. So this is going to be 5 log base 3 of x minus 7 plus 2 log base 3 of x plus 9.
I have a question.
Yes.
So that 3,
Yes.
that's on the second part, the log 3 of x minus 4, is that 3?
The base of this log.
Okay, so then the 3 that's above the x plus 2, is that the 3 that's in front of the log?
Yes.
Okay, so what if there was another, like, power? Would it go in front of the log? Of
Yes. If there was a power there, it would be out front here.
Yeah.
Just like in my bottom terms. I had a 5 on that one and a 2 on that one. That's why there's 5 out front here. There's a 2 out front there.
So if it was x plus 2 to the y minus 3 power, then you would have y minus 3.
Yeah. We would. Yeah. Okay.
It doesn't really matter what it is usually.
Right, we put out front. The exponent goes in the front. Right? So we've expanded out the log. Okay? Product rule, quotient rule, and the power rule. All involved these. Right?
Where's the quotient? Oh, no.
The subtraction.
Okay.
Because there's a fraction, we got to remember fractions made by b divide, right? There we go. Right? So that's where that comes from, right? Now, going the other way, it's easier. The other way is simple. So, let's say I want to go the other way. Okay. So now you get, it'll be something like this. It'll say write as a single logarithm. And so now we're going to end up with something like this. Let's see, 2 log base 5 x plus 9 plus 3 log base 5 of x minus 7 minus 9 log base 5 of x plus 10 plus 6 log base 5 of x minus 3. There you go. Okay? I'm going to write this as a single logarithm. This way is easier. Okay? So it's going to be log 5. I got a subtraction there, so that's my fraction bar. And then everything on this side goes on the top. Everything on this side goes on the bottom. So on the top, we're going to have, mark here somehow. What was this? This was what? X plus
9.
Okay, and somehow I lost. Oh, there. Put it back in there. All right. So this is going to be x plus 9 squared. This will be x minus 7 cubed. On the bottom, we have x plus 10 to the 9th, and then x minus 3 to the 6th. Right? We're going that way easier. Right? But now we want to actually solve for x, whatever it may be. Right? So, for example, still copy? Good, you're good? All right. So, for example, we want to solve for x. So we want to do something like this. So we want to do something looks like this. Let's say that. We're going to solve that for x.
What is that?
Yeah. Is that like the power or something?
Yeah, 5 raised to the 2x plus 9.
Oh.
Yeah, I thought that was.
Is that
8
like
raised.
floating in the- Is that an elephant? What is it?
Okay. So x in this case is in my exponent. The way I get to my x is by doing logarithms, okay? So whether you do log or ln, it doesn't matter. I can do it either way. But let's use log base 10. So I'm going to take the log of both sides. I'm going to do log of this side. We're going to do log of this side. By the power rule, this comes to the front, and then that would come to the front. And so we'll get 2x plus 9 times the log of 5 is going to equal 3x plus 12 times the log of 8. Okay. Right? Well, let's see, on the toy, we can do the log of 5. .6989, so 6990. Equals we can do the log of 8 on the toy. 0.9031. Alright. Well, now this is just basic algebra solving for x. So the next thing I want to do is, well, let's take care of our distributive property. Do it that way. So this is going to be 1.398x this will be 6.9.291. This will be 2.7093. And then this will be 10.8372. Yes.
Wait, so how did you get all of those numbers?
0.6990 times 2.
Distributive, right?
Distributive property. Okay. So I did my distributive property. So 6990 times 2, 6990 times 9, 3 times the 9031, 12 times the 9031. Right? So now, we want to solve for x. Well, how do we solve for x? We get the x's on one side, we get the numbers on the other side, and I like to keep x positive. So let's take the 1.39x and move that over. So we're going to subtract 1.398x. We're going to subtract 1.398x. So this will give me 6.291 is going to equal 1.3113x plus 10.8372. Next step is to bring the 10 to the other side. We do that by subtracting. So subtract minus 10.8372 minus 10.8372 this will give you a negative and then we're down to the last step, which is just to
May we interrupt you briefly?
You're bringing me goodies?
We are.
Ooh.
I'm here with Jill, who's on the executive committee with me, because it's Faculty Appreciation Week, and we want to acknowledge in front of all your students how much we appreciate what you do every day. So from the executive committee, thank you.
Thank you very much.
Absolutely.
Right.
And you all can write notes to your faculty on the brown paper wall downstairs, or there's a little note writing station, but please take a chance this week to thank your faculty, because we certainly appreciate what they do. Thank you.
Thank you.
And now it's on video for.
Now
Now it's on video forever.
Alright. And we get done with this, we end up at negative 3.466. Alright. Good. Alright. Okay. So the way we get the exponent is by doing logarithms. Okay? Whether you do LOG or LN, it won't matter. Either way, I will get the same answer for this. Now, how about one if I had one like this?
Are we still solving for x?
Yep. We're going to make one slight modification. Interesting. I just want to make that an x minus 4. Make it so it turns out to be a real number. All right. So we got this. So the first thing I want to do is making use of my properties. We got a subtraction there. That means quotient rule. So this would be the log base 3 of x minus 4 over 5 equals the log base 3 of x plus 2 over 7. Okay? That was quotient rule. After all, subtraction means a fraction.
Yeah, that rhymes.
Subtraction means a fraction. In terms of my rules. All right? Okay. All right. Everybody follow that step, right? All right, now we go to my next step. My next step is going to be this. Now it becomes easy. That's my next step.
They cancel out.
Remember I said that if the log of A
Oh.
was equal to the log of B, then A had to equal B. So yes, the logarithms go away.
There's no name for that rule. So it's not like
Let's see, we call it the Michael St.John rule. How about that?
I don't think I can find that on the.
No, probably not. But if you want to name it. All right. So now this is just a simple proportion. So the first step is to cross multiply. So this will be 7 times the x minus 4 is going to equal 5 times the x plus 2. 7x minus 28 is going to equal 5x plus 10. All right. So the rest of this should not be a problem, right? Get the x's on one side, get the numbers on the other side. So we're going to subtract the 5x, and we're going to add the 28. Subtract 5x, add 28. We end up with 2x is going to equal 38. Last step, divide by 2.
So if one of those log base 3s at the top in the beginning of in the original problem is something else like log base 4 or something like
Then
that.
we change, then they don't just disappear. So they gotta be the same base. Right? Now again, like I said, I had to play with the numbers because I do need to make sure when I actually get an answer, here I got x is 19, right? I need to make sure that when I plug that number in, I do not violate the fact that originally this actually was a logarithmic problem. Okay?
With the fact that it says log in it,
So really what I need to know is if I plug 19 in there, do I end up with everything being positive? So 19 minus 4, that's a positive number, I'm fine. 19 plus 2, that's a positive number, I'm fine. Okay? So 19 is a valid answer. Okay?
Why can't it be negative?
Because you cannot take the log of a negative number. We said that earlier. Remember?
it's a rule.
Yes. You cannot, remember I asked you what the log of 0 was? It was undefined. I asked you what was the log of negative 5. You was undefined. Right? So we do need to make sure when we get an answer that it actually works in the original intent of the problem. The original intent of this problem was that it was a logarithmic problem.
So when you check it, are you just, you're not...
I just go right up here.
Okay.
All I gotta do is see, is that gonna be positive? That's all I need to know. I don't care what it is. I just gotta make sure it's gonna be a positive number.
Okay.
Because I can only do logs of positive numbers, okay? Okay. Okay. Now, what about solving ones of this type?
I'm sorry, real quick.
Yeah.
The last problem, that was the one, that's the A equals B, right?
If the log of A,
Equals log.
the log of B, then A has to equal B. Yes.
So if we had a problem like this one that we just did, and it was x plus 4, or I'm sorry.
Right, that's why I changed, if you notice I changed the sign because I wanted to make sure it was going to come out to be a valid number.
Right, but
That's why I did that.
if we did all of this and we got down to x equals something that when we put it back into check made that negative,
Then there would be no valid solution to that problem.
So that would be the answer, right?
Right.
No one else. Okay,
All right, how about this one? E to the 2x equals 20. What's the opposite of e to the x?
Natural log.
Ln, okay? Whenever it's got e, you got to use natural log. Whenever it's got natural log, we have to use e, okay? Those do pair up. So I would do the natural log of this. I do the natural log of this. Natural log and e go away. So we get 2x equals the natural log of 20. Last step is divide. And then x would be whatever that comes out to be. So that's just a matter of plugging into the toy.
1.197.
So 1.498, let's call it. We'll round it up. Okay. Right. Okay. And so then conversely, if I have one that look like this, that's a 60 with the dots. So I want to solve that one. Well, again, first step is going to be divide. Divide by 6. Divide by 6. So the natural log of 4x is going to equal 10. What's the opposite of ln? E. So this would be E, this would be E. So we get 4x is going to equal E to the 10, whatever that is. And the last step now would be divide by 4. So we divide this by 4, we divide that by 4. And so this will give you some number.
Yeah.
I'm sorry.
Maybe it's easy to
Yeah, why would it be e to the 10? Why not just e times 10?
No, because we got to do the opposite of ln is e to the x.
Oh.
So e to an exponent, right?
Okay.
Just reversing it.
Right.
So it's e
Text
to
looks like
the
it's 55 or 6.
So the E of 10 is 0?
So 5506.6.
Yeah.
0.6.
Yeah.
Right? Oh. How about one like this? Again, solve for x. Log base 3 of x minus the log base 3 of x plus 5 is going to equal 5. So first off, I can write it as a single logarithm on this side. This will be the log base 3 of x over x plus 5 is that, okay?
And that's the power rule?
Quotient.
Say again?
Quotient.
Quotient.
The subtraction means division.
Subtraction is fraction.
Subtraction means fraction.
Subtraction of the fraction.
And then I'm going to change from the log form into the corresponding exponential form. So we get x over x plus 5 is going to equal 3 to the 5th. What?
How did?
Is that a rule?
Because you're taking the log.
All we're doing is changing from log form to the exponential form. We had that down earlier. You had that on today's quiz.
I can hardly remember today's class at this point.
It was so long ago, yes.
So you can just take the log and just let that go. That doesn't matter anymore. And then take the number that is below it and then put it on the other side and make the number that's on the other side the power. You can just do that.
Yeah, because all we're doing is changing from one form to the other.
That makes so much sense.
They're interchangeable.
Oh, yeah.
They mean the same thing.
Okay? So we can find out whatever 3 to the 5th is. 243. So we get x over x plus 5 is going to equal 243.
Can you cross multiply this now?
So now we're going to, so we're going to have x is going to equal 243 times x plus 5. So x is going to equal 243x. 243 times 5,
1215.
1215. We want to get the x's on one side. So if I bring this one over, so minus 243x minus 243x. We get a negative 242x equals 1215. Last step. Huh?
Yeah,
1215 divided by negative 242.
Divide by a minus 242. Divide by a minus 242. And we get that x will be
Negative 5.02.
5 point what?
02. 06611.
And that's a negative, right?
Yep.
So, given what I said earlier, does this have a valid solution?
No.
No. Because if I take negative 5.02, I have a problem. Okay? So in this case, again, like I said, you do need to check. Okay? The way this one works out is there is no valid solution. Because when you take the negative 5.02, plug it in there for x, I end up with trying to take the log of a negative number, which cannot happen. All right? So we can take an expression, we can solve it for x. Well, how about one like this? There's a fun little one. I want to solve that for x. This problem really is no different than solving this. There really isn't much difference between the two. Okay? This is factorable, so let's look at the one in the red first. Nice little quadratic, right? It can be factored. It'll be an x and an x. This is positive, but the middle term is negative, which means both of these have to be negative. And then we need two numbers, multiply together to give you 6, and have a total of 5. So 2 and 3, right? So 2 and 3, and this equals 0, which meant that either the x minus 2 had to equal 0, maybe, or the x minus 3 had to equal 0. And so here we ended up with either x was 2 or x was 3. This here factors basically the same way. This is quadratic in form. Instead of x minus 2 and x minus 3, however, for this one, we're going to get e to the x minus 2, e to the x minus 3. So we get e to the x minus 2 equals 0. E to the x minus 3 equals 0. And now we want to solve each one of those for x. So we're going to bring the 2 over, and we're going to bring the 3 over. So e to the x could equal 2. E to the x could equal 3. What's the opposite of e to the x? Natural log. So ln, and so x is going to be the natural log of 2, whatever that is, and then x would be the natural log of 3. Right? So those ones are called quadratic in form. And then the last couple of problems you have on your homework is actually goes back to stuff we've seen already. And that was given that a sub t is equal to a naught e to the kt. And we've seen that already, right? We'll be able to have more of that in the last section. So this at equals a naught e. Again, A naught was the initial amount, K was the rate, T was the time frame, and then A sub T, right? So given something like this, if the initial population is 200, grows to 500 after 10 days. How many will be present after 25? So something like that. And again, if it's rate of growth, K is positive. If it's rate of decay, K is negative. Right? So really, there is a two-step process. I take the first bit of information, find K. Once I know K, I can actually answer the question that they want. So we got that A naught is 200. A sub 10 is 500, and A sub 25 is what I want to find. So I use the first two pieces to get my value of K. So we get 500 is going to equal 200E to the 10K. Divide by 200. Divide by 200. So this will give me 2.5 equals E to the 10K. Opposite of E, natural log. So the natural log of this side, the natural log of that side. And so we get that the natural log of 2.5 is going to equal 10K divided by 10 divided by 10. Okay. And that'll give us the rate.
9%.
So K is going to equal 0.09, and let's call that a 2. Okay. So now we can answer the question, which is how many are going to be present on day 25. And so on day 25, we got A sub 25. My A naught was what, 200?
Yeah. Wait, so now we fill in 200 for 25, that's not K?
No, my 200 was my A naught, right?
Right.
So my A naught is 200. A sub 25 was what we're going to find. So it's going to
this
be
is
200 E to the 0.092 times 25. And that'll tell me how many will be present on day 25. And so, to the nearest whole number, we're going to get 1995. Okay. Again, two-step process. Find the rate, answer the question. Okay?
That's 199.5 or 1995?
1995. Again, the okay. Board is really picky. Yes. Okay. All right.
That's all the good stuff.
All right. So then, there is one last thing for the day. So, when are you done with this? We're done for the day.
Is there a lecture tonight?
What? No, there's not, actually. The next one is not until next week. One. And
I'm following logarithm.